In this video, we are going to talk about partial derivatives. We are focusing two important concepts, first order partial derivatives and second order partial derivatives. There are two first order partial derivatives available if the function is in terms of x and y. The partial derivative of the function f with respect to the variable x is denoted as dou f by dou x, or sometimes we can write f sub x. Similarly, the partial derivative of the function f with respect to the variable y is denoted by dou f by dou y. Sometimes I can say f sub y. Similarly, the second order partial derivatives goes like this. If I say dou squared f by dou x squared, the meaning is this is equal to dou by dou x of dou f by dou x. That means we have to differentiate the function f partially with respect to the variable x two times. I can also denote this as f sub xx. Similarly, the two-time partial derivative with respect to the variable y is denoted by dou squared f by dou y squared, or I can write f yy. And we have two mixed partial derivatives. Mixed partial derivative means we have to differentiate the function partially with respect to x one time and partially with respect to y one time. I can also say we can partially differentiate with respect to x one time, y one time, or we can do partial derivative with respect to y and x one time. So these two we called mixed partial derivatives. Mixed partial derivative means I can differentiate one time with respect to x and I can differentiate one time with respect to y. Please remember, in any partial differential equation, the mixed partial derivatives are always equal. That means if I perform the first derivative with respect to x, second with respect to y, or if I perform the derivative first time with respect to y, second time with respect to x, both will give you the same answer. The first one we denoted as f xy, and the second one we denoted as f yx. Okay, so this for this and this for this. Let us do some problems. Question number 1, we are asking to calculate fx and fy, and we have the function f of x comma y equal to x squared y plus 2x plus y. So that means first I have to calculate fx. The meaning of fx is dou f by dou x. That means partial derivative of the function f with respect to the variable x. And please remember, whenever you perform partial derivative with respect to x, you have to treat the other variable as a constant. So here the other variable is y, so we have to treat y as a constant term. So look at this first term. We have given x squared y. Since I am focusing the derivative with respect to x, derivative of x squared equal to 2x, but I have to keep this y as a constant term. Plus, move to the second term. We have 2x, derivative of 2x with respect to x will be 2. And in the third term, we have y. Since we are differentiating with respect to y, with respect to x, this y will become 0. Then I have to calculate dou f by dou y, or I can say f sub y. So this time we have to differentiate the function with respect to y. That means I have to treat the other variable x as a constant one. So derivative of x squared y with respect to y will give you x squared, because x squared is constant. This y with respect to y will give you 1. Move to the second term. In the second term I have 2x. So derivative of 2x with respect to y will be 0. Move to the third term. We have y. Derivative of y with respect to y will be 1. So this is my answer. Question number 2. Again we are looking for fx and fy. So fx means partial derivative of the function f with respect to x. So here we have sine xy. So I have to apply chain rule. First you have to write the derivative of sine. So derivative of sine is cosine xy, and then using chain rule we have to differentiate this with respect to x. So derivative of xy with respect to x will be y. Second term cosine x. So the derivative of cosine x will be minus sine x. Then fy. Again, in the first term, we have both variables xy. So derivative of sine will give you cosine xy, and derivative of xy with respect to y will be x. In the second term, there is no y, so derivative of cosine x with respect to y will be 0. Question number 3. We have given the function as x into e power xy. So let me calculate fx. So here we have x into e power xy. So I have to apply product rule, u times v. So what is product rule? U multiply v is equal to u dv plus v du. So I'm going to apply product rule here. So keep x as it is. Derivative of e power xy with respect to x will be the same, and by chain rule derivative of xy will be y plus v du. V is e power xy. Derivative of x with respect to x will be 1. Then fy. Again for fy also we apply product rule. So we have x into e to the power xy. This time we are differentiating with respect to y. So derivative of xy will become x. Plus e power xy. Derivative of x with respect to y will be 0. So this term will be cancelled. So we have fy equal to multiplying these two, x times x power 2 e to the power xy. Question number 4. This is my function ln of x square plus 2y. So if I write fx, we know that derivative of ln is 1 over x. So derivative of ln x power 2 plus 2y, that will be 1 over x power 2 plus 2y. And after that derivative of x power 2 will be 2x. Derivative of 2y will be 0. Then fy. So fy means derivative with respect to y. So we have 1 over x power 2 plus 2y multiplied by derivative of x power 2 is 0. Derivative of 2y with respect to y will be 2. Sometimes we are asking to calculate the derivative at some specific points. So here we need to find fx at 2, 3 and fy at 2, 3. So as usual, first you calculate fx. So fx will be, here y is constant, derivative of x power 2 with respect to x will be 2x. So we have 2xy. And here second term there is no x, it will be 0. We are asking to calculate fx at the point 2, 3. That means in the result of fx, replace x by 2 and replace y by 3. So that will give you 12. Then calculate fy. That means derivative of the function f partially with respect to y. So that will give you x squared plus 2. Then I have to calculate fy at the point 2, 3. So that will give you 6. Question number 6, we are asking to calculate all the second order partial derivatives. So before finding the second order partial derivatives, we have to calculate first the first order. So fx equal to 3x power 2 y power 4 plus in the second term derivative of x squared y will give you 2xy. Then if I calculate fxx, that means derivative of this again with respect to x one more time. So here this will become 6x, y power 4 is constant. Derivative of 2xy with respect to x will be 2y. Then I have to find fy. So fy means first we differentiate this with respect to y. So that will give you 4x power 3, y power 3. Second term will become x power 2. Then fyy. Fyy means take fy, again differentiate with respect to y. So this will give you 12x power 3, y power 2. Second term will be 0 because there is no y. Then we have to calculate fxy. So fxy means take the result of fy and differentiate again with respect to x. So this will give you 12x power 2, y power 3 plus 2x. if I find fyx, that means take fx result and differentiate with respect to y. So this also equal to 12x power 2 y power 3 plus 2x. I told you before, all the partial derivatives, the mixed partial derivatives are equal. Next problem, we are asking to calculate the mixed partial derivative, that is dou squared f by dou x dou y, is it equal to dou squared f by dou y dou x for this function f of x comma y equal to x plus y plus x into cosine y. So first let me calculate fx. So fx will be 1 plus cosine y. Fy, that will be 1 plus x is constant, derivative of minus cosine y will be minus sine y. Then I can find fxy. So that means the result of fy will take, and we differentiate this again with respect to x. So derivative of 1 will be 0 and second term will be minus sine y. Similarly, if I calculate fyx, that means take the result of fx, differentiate with respect to y. So here 1 will be 0, derivative of cosine y with respect to y will be minus sine y. So we come to know that these two are equal. This question we have already done. Same model, second order partial derivatives of the function x squared sine y, y squared cosine x. So first we will find the first derivative fx. So what is fx? 2x sine y minus y power 2 sine x. Okay, here this y power 2 is constant, derivative of cosine is minus sine x. If I find fy, this will be x squared cosine y plus 2y cosine x. If I find fxx, that means take the result of x, differentiate again with respect to x. So this will give you 2 sine y minus y squared, derivative of sine x will be cosine x. If I find fyy, so what I do, take the result of fy, differentiate this again with respect to y. So this will give you minus 2 sine y plus 2 into cosine x. And finally, we have to calculate fxy. That means take the result of fy, differentiate with respect to x. So this will give you 2x cosine y minus 2y sine x. We know that fyx also same, 2x cosine y minus 2y sine x. Question number 9 you can try. I will explain question number 10. So we have to find all the second order partial derivative. So first one fx. So derivative of cosine 2x with respect to x will be minus sine 2x followed by derivative of 2x will be 2. In the second term we have x squared e power 5y. So derivative of x squared will be 2x and e power 5y is constant. In the third term there is no x, it will be 0. Similarly, if I calculate fy, the result will be 5x power 2 e power 5y plus 6y. F double x, that will be minus 4 cosine 2x minus e power 5y. Fyy, that will be minus 25 x power 2 e power 5y plus 6. And finally, fxy, that will be minus 10 x e power 5y, and fyx also same, minus 10 x e power 5y, because we know that mixed partial derivatives are equal. So these are the exercise problems for you. Work it out. See you in the next video.